So the first question, basic concept of classical mechanics. Classical mechanics is a part of physics that describes how the everyday things move and how their motion change because of forces. So if we know how things are moving now, classical mechanics allows us to predict how they will move in the future and how they were moving in past. Classical mechanics use a common sense notion of how matter and forces excite and interact. It assumes that matter and energy have defined noble attributes such as location in space and speed. Non-relativistic mechanics also assumes that forces and instantaneously. And the next question, rigid body, rotation about a fixed axis. Rotation about a fixed axis, all particles move a circular path about the of rotation, and the motion of the body is completely determined by the angular velocity of the rotation. And the rotation around a fixed axis is a special case rotational motion. The fixed axis hypothesis encloses the possibility of an axis changing its orientation and cannot describe such phenomena as hobbing and presentation. The next question, ways to set the motion of a material point. Ways to set the motion of material point. There are two methods of the set the motion of a material point. The first is a vector method, the next is a coordinate method, and then the next is the natural method. The first, vector way. In the vector method, we specify in motion the position of a point is determined by radius vector drawn from a fixed point and in the selected reference frame. And the coordinate method for specific motion. In this way, specifying the motion in the selected coordinate system, the coordinates of the moving point are set up function of time. And the next natural way of setting the motion. A natural way of setting the motion is a natural way of setting motion. We suppose to determine the motion parameters of a point in a moving reference frame, the beginning in which considers with a moving point, and the axes are tangent, normal, and be normal to the trajectory movement of a point each of positions. The next is the collisions theory. Collisions process, general collisions, elastic collisions. So collisions, what is a collisions? Is any collisions which the external forces can be neglected and the momentum is conserved. The collisions process, completely inelastic collision. Total kinetic energy after the collision is less than before, and the conservation of momentum gives the relativity. And elastic collisions. Elastic collisions, the kinetic energy and the momentum is conserved. The next is projectiles. Projectiles without resistance, projectiles with resistance. Projectiles motion of a form motion exerted by object of particle that is projected near the Earth's surface and moves along a curved path under the action of gravity only. The motion of projectiles without air resistance can be separated into two components: motion in the vertical direction where the force of gravity is present, and the horizontal motion where the force gravity is zero. Air resistance creates force that is always directed against the direction of motion, and in this situation our formula equal to the Fa equal to the minus Fv and V vectors times. The next, vector and scalar physical quantities. So there are two main types. The quantities is vector quantities, scalar quantities. Vector scalar quantities is only magnitude. For example, mass, for example, is a speed, for example, energy. And scalar quantities have magnitude, have the directions. For example, is force, for example, is acceleration. The next rigid body is planar motion. Rigid body is planar motion. We proceed by demonstrating that every motion is a planar rigid body is associated with a single angular velocity omega and angular acceleration a, describing the angular displacement and the arbitrary line included in the body relative fixed direction. And the next kinematic side characteristics of motion in the rigid body and the expression of the kinematic characteristics of its points. So in physics, a rigid body in a solid body in which deformation is zero also can be neglected. And the characteristics of rigid body is the first is all lines of rigid body have the same angular velocity omega and the same angular acceleration a. The next characteristics is a rigid motion can be discriminated into the translation arbitrary point followed by rotation about the point. And for motion relative to untranslated reference, for example, in this picture, we say that for which describes the motion is particles A observed at V relative to untranslation event at V. And we in this picture we say C, and we say that this formula RA equal to the RB plus RA divided B. The next equation of rigid body dynamics. For two-dimensional rigid body dynamics problems, the body experience motion is one plan due to forces action in this plan. A general rigid body subjected to arbitrary forces in 2 is shown. The next fundamental interactions, fundamental physical theories. So the first fundamental interactions are the interactable forces that act between the elementary particles composing all matter. And the physics have described 4 fundamental interactions. The first, gravitational, electromagnetic, weak nuclear, and the strong nuclear. There are of the 4 fundamental interactions are medical by intermediate quanta of particles, also known as Joule bosons. Gravity quanta, the gravitation remains theoretical have unflight the electromagnetic and the weak nuclear forces into a single, more fundamental force named the electroweak interactions. So the next is a variation principle, Hamilton's principle. In science, especially in mathematical studies, a variance principle is one of the enables a problem to be solved using calculus of variation, which concerns finding functions that optimize the values of quantities and depends in those functions. For example, the problem of determining the shape of Hunting chain substances above and catenary can be solved using variations calculus, and in this case the variational principle in the following: the solution of a function the minimally the gravitational forces potential energy is a chain. And the Hamilton principle is a Hamilton principle with William Roman Hamilton formulates in this principle is states that the dynamics of physical system are determined by variational problem. For a functional basis, we want single functions in the Lagrangian, which may contain physical information concerning the system and forces actions it. The next is a rotation of the body around the fixed point. So rotational around the fixed point, fixed axis, is a special case of rotational motion. The possibility of changing its orientation and cannot describing such phenomena as wobbling or precession. And according to Euler's rotation theorem, subtenuous rotation along a number of stationary axes at the same line of impossible. The next is the fundamentals of Hamilton mechanics. Hamilton mechanics, the function of the two variables momentum p and x, position x, and in this situation our formula hp x equal to the px minus lx, l and x prime, and where x prime and p dh divided dp equal to the minus x, and the dh divided by minus dx equal to the minus p. The next kinematic characteristics of the relative motion of material point. So in the kinematic study of the geometry of particles, rigid bodies, and the motions, it is the positions, it's the velocities, it is and the accelerations. It's a coordinate system in interaction writes a vector expression, and the basic kinematics characteristics of moving point are velocity and acceleration, the values of which are determined by equation of motion and using the first x, y, and the z of or of the air. The next, Hamilton's dynamics. Hamilton's dynamics is about coordinates changed, and it's clear from the above that there is not shortage the coordinates for describing the ideal fluid. The most intuitive form of fluid equation is the Euler's form, and these processes have non-Hamilton's descriptions. And the Hamilton system in dynamical system governed by Hamilton's equations. And in physics, this dynamic system describes the evolution of a physical system. Of such a planetary system is an electron of an electromagnetic field. The next is basic postulates of Newton's dynamics. The three Newton's laws are basic postulates of Newton's dynamics. Postulate number 1 is the principle of conservation of momentum. The total momentum of isolated system of particles relative to one inertial reference frame is coordinated in time. So the same is true the particular for free particles. And postulate number 2, if a particle's mass is the subject of interaction with particles m1 and m2, then at each instant t, the rate of change of this particle's momentum relative to an inertial reference frame equal to this formula. And the postulate number 3, the law of action and reaction. Newton's third law states that when the two bodies interact, they apply forces to one another that an equal magnitude and opposite in direction. And postulate number 3, the third law of, also known as the law of reactions. The next question is a Lagrange equation. This question, basic theorems of particle dynamics. Basic theorems of particle dynamics the rate of change of the momentum pt and of a system of particles, the relative to an inertial from the inertial from reference equal to the total external forces and actions the system at time L, and the rate of change of the angular momentum of particles related of zero is given by the all these formulas. And the Hamilton's example. So for the Hamilton's ocular example, the Hamilton's is HPX equal to the PX prime minus 1 divided 2 KX MK square plus 1 divided 2 kx square equal to the p square divided 2m plus 1 divided 2 kx square. In this three dimensional generalized of Hamilton's equation, in this formula hpx by x equals z equal to the px x prime plus p y prime plus pz and z prime plus minus lx y z x prime y prime and z prime. The next question laws and the theorems of the dynamics particle systems. So momentum of the system is a momentum theorem. The first m derivative of the momentum vector of the many body system equals to the vector sum all external forces and one particular of the system. And the conservation of momentum theorem, if one external acts of particle systems, then the total momentum of the whose system remains constant. This is valid of isolated system. And so the next square variational principle, Fermat principle. Variational principle is a in physics is an alternative method for determining the state of dynamics at the physical system by identifying an extreme minimum, the maximum, and the saddle point of the function. Size of function, the sum of A equal to the K1 minus K2, and the Hamilton's equation. And the Hamilton's is a function of the two variables, momentum P and the Px, Hpx equal to the Px prime minus Lx times x prime. So, Cauchy Lagrangian equation. The Lagrangian equation is a statics with externally weight to the same the example of the Lagrangian mechanics, and is a sample example for in the two demonstrate harmonic and the ways f equal to the du divided dx equal to the minus kx, and the Newton's equation is the minus kx equal to the ma. The next is the next question. The movement of particles is a file stationary nucleus of an atom, differential equation of cross-section. So movement of two changed particles A is the field of the nucleus. The mass of the nucleus, a mass A, the core is in cortical rotational motion. A depends for a mass in distribution over the volume, the atom, and the speed of its rotation. At this, a moment of pulse L equal to the L plus S. And the differential scratching of cross-section is the ratio of the number and the particle sketching per unit as time per solid angle element du equal to the flux density of the incident particles, and the types of equilibrium with classical mechanics. There are three types: equilibrium, stable, unstable, and the indifferent. The equilibrium is called stable if, after small external influence, the body returns to original state is equilibrium. And the equilibrium is called unstable if with a seat displacement of a body. So equilibrium is called indifferent if with a seat displacement of the body. The next question is the basics concept and the theorem of analytical mechanics. Lagrange's equations of such kind I equal to the 1, 2, and the second order differential equation is the number of degrees freedom of the system. Qi is a coordinate system, and the generalized speed is a linear speed, is the angular and the sectoral speed. The next generalized force, potential force. Generalized force find as a Lagrangian mechanics, where they play a rate of congruent mechanics, where they play a role of conjective generalized coordinates. They are obtained from applied forces F equal to the G1 and acting on a system, and the virtual load is generalized by the force and coefficient of the variations of generalized coordinates. Basics of Lagrangian mechanics, fundamentals of Lagrangian mechanics. So, basic concept of theorems of analytical mechanics. So Lagrangian, generalized force and potential force. So generalized force find as the Lagrangian mechanics, where they play a role of quantitative general coordinators. They are obtained to generalize from the apples F equal to the Y 2 and acting on a system that has its configuration defined in terms of generalized coordinates. And the basics of Lagrangian mechanics, fundamental Lagrangian mechanics. And the Lagrangian mechanics describes as a mechanical system with a parts L consists of the configuration space M, and in this formula T equal to the 1 divided 2 sum of N K equal to the 1 mk v square and k. That's all. Thank you for attention.